Above ground, it seems just another day in London. But 60 feet down, beneath the historic streets, an army of 20,000 people are laboring on Europe's most massive engineering project since the Channel Tunnel. As they burrow under the ancient buildings, there must be no mistakes. This is the Jubilee Line extension to the London Tube. For 6 years now, the engineers have been digging tunnels, laying track, building stations, bringing the world's first subway system into the 21st century. This $4.5 billion project has encountered more than its share of technical difficulties. But overcoming obstacles is the MO for the world's oldest and greatest subway, London's Underground, affectionately known as the train in the drain. London is an ancient city. When the Romans first arrived more than 2,000 years ago, there was already a settlement here. Over the centuries, it's been ruled by countless kings and queens. It is here that Shakespeare wrote his plays, and modern democracy was born. But London today works thanks to something invented 150 years ago and improved constantly since: the tube.
You can appreciate the importance of the tube to London when you think of one of our little tube lines is the equivalent of 7 lanes of highway each way if you did it by car. Put that on a map of London, put the car parks in, there is no London left. And I think if you think of London and London Underground, you're thinking of the arteries of a body. And you're thinking about the thing that runs deep through its heart and keeps it alive.
If the tube has a heart, it's Oxford Circus, one of the world's busiest subway stations. Some 87 million people pass through it each year. The London subway has a simple mission: move a great number of people efficiently, quickly, and hopefully safely. 800 million travelers actually use the system every year. But the risks are enormous when you transport millions of people at high speed through 106 miles of narrow tunnels. The tube has seen its share of accidents, bombings, and fires, and it's been more than just a transport system. Above ground, the streets grow more and more congested. To remain true to its mission, the London subway is now undertaking the Jubilee Line extension. The new line will relieve the desperate pressure on the busy streets, as well as reducing the crowding on the subways themselves. It will also provide Londoners with a safer, more efficient way of traveling. The line is the first new subway project in London for 20 years. It will add 10 miles of new tunnels and give travelers access to areas of London never served by the tube before. It will link to the new business complex at Canary Wharf, and when it's finished, will be able to carry 50,000 passengers an hour to the Millennium Dome. Many of the engineers for this project are seasoned veterans of the Channel Tunnel, the 31-mile undersea link between England and France. But the Jubilee Line presented these veteran engineers with a greater technical challenge than the tunnel. The Jubilee Line tunnels have to be carefully threaded through an already overcrowded subterranean city, packed with older tube lines and a spaghetti of underground service line and cables. And there was another challenge. The waterlogged soils near the Thames River can cause collapses or subsidence. Fortunately, the engineers have at their disposal the latest tunneling technologies, but they are on a tight timetable, and there is no margin for error, no mistakes.
If we had had a problem in Westminster, it would have been an international catastrophe. It's as bad as that, so we had to get it right.
One of the prime concerns for the extension was tunneling beneath the British Houses of Parliament and Big Ben. Big Ben may be an international landmark, but the Victorian builders gave it poor supports. Unfortunately, 2 new Jubilee Line tunnels pass a mere 20 meters from the building's frail foundations.
If you can imagine Westminster itself, to one side you've got the Big Ben structure and all the Westminster structures tied in with that building. You've got the District and Circle line, you've got a major sewer running longitudinally with us, 8 feet in diameter, taking half of London's sewage through it. We've got water mains, gas mains, and really it's amazing that we managed to hold everything up.
The bane of all tunnelers is subsidence. When tunnels are dug, especially through water-filled soil, there is a natural tendency for the ground above to sink. To check the subsidence, the engineers came up with an ingenious solution. Some 7,000 electronic monitoring points were clamped to the historic and the not-so-historic buildings surrounding the Westminster area. Any movement would instantly be detected by the sensitive monitors. Detecting subsidence is one thing, preventing it is another. So engineers came up with a sophisticated technical fix: permeation grouting. This process calls for injecting concrete into the ground above the dig sites. First, large main shafts were dug. From these shafts, smaller injection tubes, marked in red, spread out under the buildings most at risk. Into these shafts and tributaries, the cement was carefully injected, stabilizing the soil.
We're still boring holes in the ground under some of the most expensive real estate in the world, a lot of which was actually constructed in the 1880s without proper foundations and is on the verge of tumbling down without assistance from us boring underneath.
One of these shafts was right outside the Houses of Parliament. To keep traffic disruption to a minimum, the work was done at night. In fact, few commuters ever suspected that they were driving over a 100-foot deep hole on their way to work each morning.
The Jubilee Line has been an enormous achievement. It's surpassed anything in the tunnelling terms that has ever been done in this country before.
The engineers' precision achieved the necessary stability, and Big Ben stands as straight and tall today as it has for 150 years. The difficulties faced by the Jubilee Line engineers and their ability to devise imaginative solutions are an integral part of London's subway's proud engineering tradition, a tradition stretching back to its very beginning. In 1850, London was the world's largest city and the most congested. 2.5 million people were crammed into 60 square miles. The city was crowded, filthy, filled with horses and carts. It was choking itself to death. The only roads were a network of narrow streets designed centuries earlier. Something had to be done. A more efficient means for moving people from point A to point B needed to be found. Outside London, there was an impressive system of railroads, but trains were not allowed into the town itself. It took the vision and innovative thinking of Charles Pearson, solicitor to the City of London, to devise the perfect solution: put the railroads underground. It was a bold idea. There was only one problem. It had never been tried before, and it might not work.
The Metropolitan chose to dig its route by cut and cover largely, which of course is basically digging a trench and then covering it over. And the easiest place to dig a trench then was in the middle of the road. So it became natural in effect to construct an artificial cutting and go down below. It was a relatively simple method in terms of technology. It is just a trench and then roofed over.
One final challenge confronted the engineers of the Metropolitan line. The engines were steam-powered. In the confined tunnels, passengers would be poisoned by the engine's toxic fumes. The solution was a steam engine that piped its exhaust into two huge holding tanks on its side. Called condensing engines, these engines made possible the world's first underground railway. Unfortunately, the solution wasn't perfect. The holding tanks quickly filled up with fumes and needed to be emptied. So how could the tanks be vented in an enclosed underground environment? This is number 23 and 24 Leinster Gardens in London's Paddington district. To the casual observer, these houses are like any other on the street. But on closer observation, it becomes apparent that the windows are false and there are no mailboxes. It is only from above that one can see the real purpose of these fake houses. They cleverly hide the subway's vent holes, where the engine's holding tanks could be cleared safely.
When the Metropolitan opened, it was successful immediately. Large numbers used it right from the beginning, and it was successful commercially. It was paying a dividend within 1 or 2 years, which was considered very good, 4 or 5%.
The first London subway, called the Metropolitan, ran for 3.5 miles between Paddington and Farringdon in the city. But the cut and cover method turned out to be enormously disruptive. It required digging up main streets to build the tunnels. In the end, this approach only added to the congestion of London streets rather than relieving them. If the subway was going to expand, a new method of construction, one less disruptive, needed to be found. Clearly, there was only one option: dig deeper. Today, for the engineers handling the Jubilee Line project, digging deep underground is a well-mastered science. What continues to be a challenge, however, is digging through the waterlogged soil under London's River Thames. Watery soil is much heavier and more likely to collapse than normal soil. In all, the Jubilee Line will tunnel back and forth beneath the Thames 4 times. The man who first devised the technique was a British engineer. Mark Isambard Brunel was a celebrated engineer. He built the first major canal in America, the Lake Champlain Hudson Waterway. In 1825, he started work on a tunnel for pedestrians under the Thames. In undertaking this project, Brunel had to solve difficulties that had no easy answers.
Brunel was very worried that he was going through soft mud at the bottom of the Thames, and there was a distinct possibility that the whole thing would fall through on him. So he devised this huge shield, whereas nowadays they're usually circular in section. This one was rectangular because it was easy to build, but a vast cast iron structure with screw jacks to hold timber boards at the front, in order that the men could advance at a very small amount at a time and feel fairly safe.
The machine that Brunel devised is the forefather of all modern tunneling machines. His innovation was to design a solid roof or shelf over the heads of workers to protect them as they clawed their way through the earth. But his design was not without faults. During the construction of his pedestrian tunnels, there were 2 collapses and 10 people drowned. But after 15 years, the 500-yard-long tunnel was completed. In 1880, plans were made for a new pedestrian tunnel beneath the Thames. The engineer, James Henry Greathead, decided to improve on Brunel's design. His tunneling machine was smaller and lighter than Brunel's, and most importantly, it was circular in shape, giving it optimum strength for tunnels. Greathead also designed the machine so that as the earth was removed, hydraulic rams pushed it forward. Workers behind the machine would then bolt cast iron lining sections into place, securing the tunnel. Finally, cement would be pumped into the area between the iron lining and the surrounding earth, ensuring a tight and waterproof fit. It was a painstaking process, resulting in only 5 feet of tunnel every 12 hours, 10 feet a day. Greathead's new tunneling machine presented the Metropolitan with a technology that would allow the subway for the first time to be dug deep beneath the city. Construction could go on without disrupting traffic above. In 1886, Greathead, with his new digging machines, set to work constructing an additional 4 miles of tunnels linking King William Street with Stockwell.
It's important to remember that the vast bulk of London's tube network was actually built by hand. It was tunnelled by hand and dug by hand. It's a remarkable enterprise in many respects, and we owe it largely to those people who beavered away underground at the turn of the century.
But now, with deeper tunnels, London's subway had a major new problem to overcome. Steam engines were useless in tunnels 60 feet underground. There was nowhere to vent their deadly toxic fumes. But the Germans had been experimenting with a revolutionary means of locomotion: electricity. Electric engines proved to be the answer. To this day, London's tube trains are powered by electricity, with the design changing little over 100 years. Each line has 4 rails, 2 for wheels, and 2 live rails that carry 630 volts of electricity. The current is picked up from the live rails by shoes on the train, powering the electric motors. The first electric engines were used in the subway in 1890. They were British-built and pulled 3 cars. For the early passengers who considered gas lights in the street exotic, the subway was a fantastical voyage into the future.
To the Victorians and Edwardians, it must have been truly astonishing. You step out into this white tiled tunnel and this train appears as if by magic. There's no steam, there's no smoke. And it must have been just overwhelming for those early travellers in many respects. It's almost akin to doing the shopping by space shuttle for us.
But the engineers made one bad judgment.
It was felt that because you were in a tunnel the entire time, there was actually no need to see out of the train. So they were built with no real windows, with very, very high back seats, and they very quickly gained the nickname of padded cells.
The Victorian engineers had solved the major early problems plaguing the subway by developing deep tunneling techniques and electric locomotion. The stage was set for the subway to expand. But there was still a problem. Where was all the money going to come from to electrify the lines and dig the new tunnels? The money to modernize and expand the London subway would come from this man, Charles Tyson Yerkes, a financier from Chicago who had made his fortune on tram cars. He was to become the driving force behind the great expansion of London subways at the turn of the century.
here was this go-getting, thrusting American setting sort of Edwardian England on its heels, to be quite honest. You know, this was the man who was going to build the underground, and build it he did.
Yerkes bought up the various competing lines and then set about electrifying them. Now all he needed was a large source of electrical power. His solution was big, bold, and expensive. Build the world's largest power station. Locals called it the Chelsea Monster.
The size of Lotts Road was a major increase on anything which had been done before that. When it opened in 1905, it was described as the largest power station in the world and was at least twice as large as that at Niagara, which of course is a hydroelectric station.
To increase the plant's efficiency, Yerkes engineers turned to a new technology for generating electricity: steam turbines.
This was another example of being far-sighted in that, of course, he was foreseeing the construction of further tube railways which would add load to the system. His engineer from America, Chapman, designed and built the whole affair.
This new technology has stood the test of time. The Chelsea Monster powered the London subways for almost a century. At peak times, it produced over 180 megawatts of electricity, enough to light a small city. By the millennium, this historic building will close, and the National Electricity Network will power the tube. With the subway tunnels now up to 100 feet below street level, it became inconvenient to move large numbers of passengers up and down from the street by endless flights of stairs. Yerkes' first solution was to use elevators, but they were soon overwhelmed. Another approach was needed. That solution proved to be an American invention: the escalator. Today, there are more than 300 escalators in the London subways, and another 118 are being installed for the Jubilee Line extension. The subway's escalators have their work cut out, covering in their lifetime the equivalent of 52,000 miles and running 20 hours a day, 364 days of the year. The first escalator was installed in 1911. These so-called moving stairs were not immediately popular, so the company went out and hired a man with a wooden leg. His job was to ride up and down the escalator all day to reassure the passengers of its safety. The American influence on London's underground went further than financing and technical solutions. Yerkes and his company left many legacies.
Right down inside the cars.
Phrases like "move down inside the car." Only on the London Underground is a train carriage called a car. Other Americanisms seeped in too. Northbound and southbound instead of the traditional up and down, and even okay.
I think we've got a lot to thank Yerkes for. It's interesting to note that after the Yerkes group of companies, stopped digging, there wasn't another tube line in central London for the best part of 50, nearly 60 years.
The cost of building and powering deep-level subways was enormous, $28 million a mile in today's money. To justify such an investment, the London subway needed more revenue. The solution was to expand the network out from central London into the suburbs. And once the trains were in place, the new riders built their houses near the stations. At the same time, the subway tried to entice travelers to come back into the city. Posters tempted people out of the suburbs to venture into London's West End at night.
Without television, of course, people tended to go out to entertain themselves. So the Underground really pushed the idea of travelling into exciting, electrically lit central London to go and see the latest film, and our publicity was very much geared towards that. And I mean, certainly, given the fact that there were very few private cars at the time, the vast bulk of people who came into central London for an evening's entertainment normally travelled by tube. It was an enormously important market to us. Travelling by tube then was as much part of the evening out as seeing the film or seeing the play.
But soon enough, Londoners were to get a very different nightlife. The Second World War hit London hard, and the subway would play a major and new role. Between August 1940 and July 1941, German planes dropped over 40,000 high explosives and millions of incendiary devices on London. It was known as the Blitz. By the end, 32,000 men, women, and children lay dead, and 30% of the city was in ruins. There were few bomb shelters in the early days of World War II, so in desperation, Londoners turned to the tubes. Because of their 100-foot depth, they offered shelter from the inferno above. Ironically, at the beginning of the Blitz, British authorities tried to keep the people out, maintaining it prevented the system from running efficiently. Londoners simply ignored the ban and just bought tickets, camping out on platforms, in passageways, and even on the escalators. For 78-year-old Joyce Morell, time has not faded her memories of those long nights in the tunnels.
Mothers and children used to wait in a queue to be let down at 4 o'clock. They wouldn't let you go down before. And they would stop there all night. People were just sitting on the concrete platforms, which was very uncomfortable. The thing I can remember most is babies screaming all night long. Parents going to sleep and leaving the babies screaming.
Accepting reality, the subway authorities came up with ways to serve its new overnight visitors better. Some trains were converted to tube refreshment specials, providing hot chocolate and buns for everyone. London had gone underground.
I think that was the one thing we did feel safe. Well, we all tried to help one another, perhaps looking after the children or trying to soothe them down, trying to help the people who were feeling very panic-stricken. One didn't really have time to think of oneself. But of course, the following morning, we didn't know whether we were going to find our houses still standing or not.
The tube took another wartime role. Some of the tunnels were converted into factories. One housed 2,000 workers who built aircraft parts for the Royal Air Force's Spitfires, Hurricanes, and bombers. Another became an improvised art gallery, protecting the precious treasures of the British Museum from the Nazi bombs. Unfortunately, the underground was never meant to be a bomb shelter. In fact, it had two strategic weak points: the river and the station entrances. A bomb exploding in the River Thames could rupture a tunnel going under the Thames and flood the entire system. To prevent this, engineers installed huge floodgates on either end of tunnels running under the river. If ruptured, the gates would close automatically. But little could be done to protect the many vulnerable station entrances. In 1941, a bomb bounced down into Bank Station, exploding on the escalator. Tragically, 56 Londoners lost their lives in the ensuing explosion. When the Blitz ended, Londoners joyously returned to the open air, but worse was to follow. In 1944, Hitler began a new campaign of terror, launching his V-1 and V-2 rockets on the city, forcing Londoners back underground. This time they had more choices. Winston Churchill, the Prime Minister, had additional deep-level tunnels built, with the idea that after the war they would be used as subways. In all, 8 tunnels were built, and many survive to this day, although they were never integrated into the system. One tunnel is still used for government document storage. And some of the original bunk beds are still there. The graffiti on the ceiling reveal the tunnel's former military purpose. Another became the headquarters for General Eisenhower. In this tunnel, Ike and the Allied command devised the plans for Operation Overlord, otherwise known as D-Day. With VE Day in 1945, the London subway could return to its former civilian purpose. During the 6 years of war, this Victorian superstructure had played an unlikely but crucial role, saving thousands of lives from Nazi bombs. But the future would present the London subway with new and even deadlier types of threats. In 1995, a terrorist attack on the Tokyo subway brought home how vulnerable subways are. Japanese extremists released a poisonous gas that killed 12 and injured 5,000 riders. Since 1990, the London subway has received over 10,000 terrorist alerts, an average of 3 a day. The confined, crowded stations are a perfect target. In the closed space of a subway, there is no escape from the blast and destructive power of a well-placed bomb. For those responsible for the tube's security, that threat demands constant vigilance.
We have to deal with people who are determined in their goals to achieve major disruption and sometimes loss of life in the United Kingdom, but particularly in London. And the Underground as a target is one which they have favoured in the past.
Until recently, the prime terrorist concern was the IRA, the Irish Republican Army. Since 1972, the IRA has waged a sustained war of terror on Britain in its struggle to win a united Ireland. Some 600 bomb attacks on the mainland have killed more than 60 people. To fight the terrorists, London's subway police force has gone high-tech. Since 1987, millions of dollars have been spent on video surveillance equipment. The subway's communications and surveillance center is a state-of-the-art facility. It provides authorities with instant access to nearly 1,500 video cameras. The cameras closely monitor all the comings and goings of the subway stations.
If you entered the system anywhere on the Underground, we would be able to collect you on the network system, pick it up in here, watch it on the television camera and follow you through on the trains. So if you boarded a train going eastbound, you'd have to get off the train going eastbound at the next station. We can pick you up and follow you across the whole system. It's probably the prime tool that keeps the policing costs at a sensible level. If we didn't have the cameras, we'd have to replace them with people, and people are a very expensive resource.
An added benefit of the cameras is a reduction in subway crime. By providing police with 24-hour monitoring, the London subways are now an unfriendly place for criminals. In fact, crime has fallen by 40% since the cameras went up. As a result, London is one of the safest metro systems in the world. But things can still go wrong, and when they do, London's elite underground emergency response unit is trained to respond quickly. The unit can deal with any kind of catastrophe, from derailments to fires to bombings. Today, they are conducting a training exercise for righting a derailed train.
Right, 2 inch and a half.
Inside, outside, inside.
Bit smaller.
No, we're all right. If we take this on this piece, yeah.
The unit is well aware that their services have been needed in the past. In February 1975, a runaway train careened into the buffers at Moorgate Station. The cars were sandwiched into a tiny space, one literally on top of the other. In all, 42 people lost their lives, and another 150 were seriously injured. The cause was never determined. It's thought the driver might have had a heart attack, but it took the rescuers a week to reach his mangled body, and no one could ever be sure. 12 years later, tragedy struck yet again. At 7:30 p.m. on a brisk November evening, a terrible, all-consuming fire broke out at King's Cross Station, one of the system's busiest. The Underground Emergency Response Unit was called into action. This was no training exercise. Before it was over and the inferno brought under control, 31 people would be dead, all the result of a cigarette that had been innocently dropped on the station's old wooden escalator. As the fire spread, passengers crowded onto the narrow platforms, blinded by dense smoke and overcome by the intense heat.
Chaos. It seemed, as we pulled up, you would have believed that you was looking at a film shoot. There was cars, there was trucks, there was blue lights. It just seemed like this is a film set. So you was waiting for the word cut, and it just never came. I was totally shocked when I went downstairs. It was very dark, and there was nothing left. It was just, I recall this very, as if it was just yesterday. There was just strips of metal of the ticket hall, which, in the heart and bustle of commuters, you'd have to sort of dodge to one side to get through.
Incredibly, the tube itself contributed to the intensity of the blaze. Trains, which continued to run, pushed oxygen into the station, fueling the inferno. The aftermath was shocking.
It was like I was standing in a field. There was just nothing left. The fire was out, but it was just very hot. There was the smell of burning in there, and it wasn't just of the wooden particles and materials in the place. It was of human beings.
The King's Cross fire resulted in massive safety changes to the London subway. The wooden escalators were replaced. Fire-retardant materials were used in new station construction, and training and evacuation procedures greatly improved. For maintenance workers, the fire brought home the sad fact that the main enemy of the Underground is its age. Much of the London subway is over 100 years old. As a result, the system is increasingly dilapidated and in dire need of a massive overhaul. Yet there is little time for upkeep because the system runs 20 hours a day, 7 days a week. Repairs can only be carried out during the 4 hours after the subway shuts down at 1 a.m. By 5 a.m., all the work must be completed, so the subway is ready for the next day's service. The loneliest overnight maintenance job is track walking. Every single inch of the underground network is carefully inspected on a regular basis. For Charlie D'Elia, that means a 5-mile constitutional through the tunnels each and every night to check the track. A maintenance army of 1,500 men and women work against the clock to keep the London Underground running. But as the system gets older, the repairs get more difficult.
London Underground's problems today come from its age. It was built in late Victorian, Edwardian period. It used old materials. It was not built to a very high standard. Today, we spend most of our time rebuilding it with modern materials to modern standards. We're about halfway through that challenge.
It's estimated that $16 billion is needed to bring the Underground up to date. It costs $400 million a year merely to repair and renew the current system. The only technology that has stood the test of time are the iron tunnel linings. So when the engineers got a chance to build a new line for the subway, they were determined to get it right. The design of the Jubilee Line extension is aimed at ensuring that tragedies like the fire at King's Cross or the accident at Moorgate never happen again. Engineers are using the latest and most sophisticated technology to build the Jubilee's tunnels, trains, and stations.
The thing that bedevils the underground is that it may have been built with vision, it wasn't built with foresight. All the holes are too small. When you get to the Jubilee Line extension, all the holes are the right size.
It's also having to tackle one problem that until now subway engineers have mostly managed to avoid: the complex and challenging geology of London itself. London is split in two by the River Thames. The bulk of the tube system was dug north of the river for one simple reason: the thick layer of clay on that side of the Thames is ideal to tunnel through. South of the Thames, the clay is much thinner. Just beneath the fine clay strata is a porridge of water-bearing soils and gravels. Engineers say that tunneling through these soils is like digging through a waterlogged beach.
The biggest hazard, I suppose, for life and limb in constructing tunnels is water. We're always very anxious to keep away from water. It's why we didn't build tunnels in the gravel south of the Thames. There are ways, of course, of building tunnels in water-bearing ground, and traditionally the principal aid was compressed air.
This technique for working in waterlogged soil was first pioneered by James Henry Greathead when he built the subway tunnels in the late 19th century. High-pressure air is pumped into a sealed chamber at the tunnel's face. The air pressure keeps water away from the digging surface, allowing engineers to tunnel more safely. But working in this pressurized environment can be risky. The high pressure necessary to hold water back is equivalent to being 40 feet below sea level. If workers emerge from the airlock without going into a decompression chamber, they face the bends and possible death. But the Jubilee Line is using a new kind of tunneling machine that pressurizes only the very front of the machine where the cutting blades are, leaving the actual workers to do their job in a normal pressurized environment. By carefully regulating the rate at which the earth is removed during the drilling process, engineers can maintain the proper air pressure at the front of the tunneling machine, keeping the water at bay. The Jubilee tunneling machines and all modern tunneling molds are direct descendants of the early British tunneling machines of the 19th century. But these new machines operate on a much more massive scale. In the past, it would have taken dozens of men to do the work of these mechanical molds with their enormous cutting blades. The monsters advance slowly but relentlessly through the London clay. For each meter of tunnel dug, 40 tons of earth is carried away on conveyors. As the machine moves forward, engineers put in place preformed concrete tunnel sections. Cement has replaced iron because it's cheaper. From time to time, these monsters bump up against London's past. At London Bridge, tunnelers found the debris from a Roman house smothered by the unforgiving mud. At the new train depot at Stratford, a burial ground for Cistercian monks was discovered. This was the site of a monastery built in 1134 and destroyed by Henry VIII in 1538. All told, archaeologists removed 678 skeletons for a respectful reburial before work started up again. The most radical and innovative aspect of the new Jubilee extension are its stations. For years, London's subway platforms have been cramped, dirty, overcrowded, and vulnerable to accidents or terrorist attack. Remembering the fire disaster at King's Cross, the Jubilee Line's new stations are designed to serve passengers safely for the next century.
We wanted to make stations that were convenient and that also lifted the spirit, that they were practical, common sense, and optimistic, that made people feel better. Concept of the Jubilee Line: convenience, ease of use, and a bit, as an extra, a bit of delight.
The new stations are enormous. The Canary Wharf station, for instance, is larger than the massive skyscraper which overshadows it. They're designed with safety in mind. Platform edge doors line each platform, greatly reducing the wind effect that fed the flames at King's Cross. And the doors also reduce access to the tracks. This will cut down on suicide attempts. Twice a week, someone falls or throws themselves onto the Underground's tracks. The Jubilee Line will also have state-of-the-art trains and cars, 59 automatic trains of 6 cars each. They will run every 2.5 minutes, moving 50,000 passengers an hour. The trains are designed with crumple zones to absorb impact, addressing the problem that killed so many people in the Moorgate crash. Each train will also have black box incident recorders, similar to those on airplanes. The escalators go through their final testing, and work on the various Jubilee stations is nearing completion. But success has come at a price, both in terms of time and budget. The Jubilee Line is substantially over budget and way over schedule. Yet technically, the engineers have achieved their objectives, building the most advanced subway system in the world. The men and women who built this massive superstructure look back on their accomplishments with great pride.
Oh, I think we're absolutely on the leading edge when it comes to tunnelling. I think other cities would have accepted the earth moving more, would have accepted the surface damage, and would have simply shrugged it off and gone back and repaired the damage. In such an intensely crowded city as we have in London, that took the very best quality civil engineering to achieve.
The demand for technically advanced subways like the Jubilee Line grows in direct proportion to the increasing congestion in urban areas. All around the globe, cities are developing new mass transit technologies to move people. In Paris, the French have recently built their new Meteor subway line with fully automatic trains. In Asia, mass transit is making great strides forward. Hong Kong opened its own subway system just 20 years ago, but already it carries 850 million passengers a year. Now, Britain's engineers too are trying to learn from the mistakes of their predecessors. They will need all their ingenuity and skill to turn the legacies of the past into the subways of the future. On the drawing board is a new type of subway train for London, the Space Train. It will increase passenger capacity by over 40% without changing the size of London's narrow tunnels. The Space Train is pioneering the concept of micro-wheels, which allows for a much larger cabin for the passengers. The Space Train also has no split cars. It's all one long tube. The London Underground has served its city well, providing efficient, safe transport in times of peace and protection in times of war. Over the last 150 years, 100 miles of tunnels have been hacked through hostile soils, while carefully preserving the ancient and historic city above. Today, thanks to the technologically advanced Jubilee Line, the train and the drain continues to be the world's leader in mass transportation, keeping its proud place as a superstructure like no other.